And here with us today inside the International Space Station Flight Control Room, we've been talking about docking vehicles. We have another one soon to launch first before it docks, and that vehicle is the SpaceX Dragon. It is the first commercial space flight to ever launch to the International Space Station. With it is carrying some special cargo, and that is some science. We love science. So here to talk with us today is Camille Eileen. She is the Space Station Assistant Program Scientist. Welcome, and thank you for joining us.
Thank you, Amiko, for having me.
Great. Well, first, before we get into the science that's going up to the station and the science that's coming down, first just tell me a little about yourself. How did you get into this field? How did you come to NASA?
Oh my gosh. I always had an interest in space and airplanes ever since I was a child. So when I decided to study engineering, automatically, aerospace engineering came to mind. So I have several degrees in aerospace engineering, a bachelor's degree from Howard University, and a couple master's degrees in mechanical and aerospace engineering. And I've been at NASA for about 10 years. I've spent also six or 7 years at Department of Defense working on ballistic missile engineering.
Okay, great. So when you first came to NASA, did you immediately start in the station science program
No,
area?
when I first came to NASA, actually I started at Kennedy Space Center over a decade ago, doing space lab processing for this back in the day for the space shuttle. Then I've worked at headquarters during the early days of exploration. And then I came to Johnson Space Center 6 years ago, where I served as the Orion Crew Module Test and Verification Manager. And now I'm in the ISS Program Science Office.
Great. Welcome. Well, we're very, very glad to have you here.
Thank you.
So let's go ahead and talk about that SpaceX Dragon. So there's something special about it, and that is that it's not just that it's the first commercial cargo, ship to go up, but the thing that's special about it is that it is a reusable vehicle.
That's right.
So it can bring stuff like science up, and it can bring stuff like science back, and that's very important. Can you explain to us what that's going to do as far as capability?
Yes, the research community is very, very excited about this capability. As you said, we haven't had this capability, at least a down mass, we call down mass capability, since the space shuttle. So the SpaceX Dragon being able to demonstrate that it could return hardware and samples is an exciting thing for the researchers. And in addition, it has a cold storage capability that's going to be demonstrated, and that's going to be able to preserve samples that need refrigeration, and that's something we haven't had.
Okay,
since
great.
Space
So that's
Shuttle.
kind of like those biological samples that we hear about. They're
Exactly.
taking the blood and urine samples and all that sort of
Exactly.
stuff. I know we have the energy experiment, and they've been taking those samples, recently, and so those would come down on that as well,
Exactly.
and they would be preserved. So that's
Yes.
good. So let's talk about some science that's going up. This is really exciting because what I understand, we have some students that are sending, and this is from 5th grade to college age. So students, there are sending like 15, I think, different participants are actually sending their science experiments up to the space station. Can you tell me a little about that program and
Yes.
how we...
The students designed 15 experiments that will be going up on the SpaceX Dragon. And these, as you said, range from fifth graders to college level students, which is very exciting, designing these kind of experiments.
Sure.
They were selected from almost 800 proposals that came from around the United States. And so it's a part of the NanoRacks module that will be flying up to the space station, and that's a multi-purpose research facility that's on board the space station that's going to house these experiments. And the experiments range from looking at the effect.
I actually have a list here. We can look at some of these because they're very interesting, and I
Very
guess you would get a
interesting.
wide range from 5th grade to college, but they all sound very, just very intriguing. So we have fermentation of grape juice in microgravity. I might be interested in that one. There is composting in microgravity, radiation effects on worms, DNA study of E. coli
bacteria,
vitamin C effects on bone density, using cacti to purify water, which would be very essential aboard the International Space Station.
That's correct.
Very interesting stuff here. So,
and when you think of the context of students designing these kind of experiments, it's really exciting, and it helps motivate them and inspire them in their studies of science, math, technology, and engineering. So unique opportunity.
Sure, I can't even imagine any better motivation.
Exactly.
I mean, for me, if I were a student and I had my science was actually going up aboard the International Space Station,
Definitely.
that's far better than my little science project that I had up in that remember that day.
Mhm.
So speaking of those science projects and stuff, we have so we are going to be bringing back some science and some hardware, and so let's talk about one of them. I know I've actually seen a lot of this taking place on the last expedition and this expedition as well. It's known as Shear, and it has to do with the polymer fluids, the rotation. You
Mhm.
want to talk to me about that?
Yes, SHARE stands for Shear History Extensional Rheology Experiment. It's a mouthful, but really it looks at the behavior of liquid polymers in the microgravity environment when they are subjected to stressing. So they're rotationally stressed, and so researchers are really interested in how that whole process and how the behavior of those polymers act in that environment. And that really helps them with designing fabrication and repair processes of using in situ materials on board the space station.
And does it have applications here on Earth?
It does, in helping to do manufacturing processes of things like liquid adhesives.
Great, thanks. Well, there really is some connection, space to Earth, and that's
Absolutely.
very important for us. There's another one that's coming down, and this one I am just completely enthralled by it. I mean, I'm just very intrigued by it, and it's the plant signaling.
Hmm.
So tell me a little about it, because it's talking about how plants grow and how we can basically re-engineer a
Hmm.
plant's basic genetic
Yes.
on how it grows. We
Yes.
can tell it how we want it to grow,
Hmm.
and that's just amazing. We're redesigning evolution almost.
Hmm.
So
And
tell
we do
me.
that on the ground, actually. But in the microgravity environment, researchers are looking at the molecular mechanisms that plants use to respond to the changes in the environment.
Sure.
And as you said, that helps them design plants or really select plants that would withstand long duration spaceflight and the microgravity environment.
Yeah, and so when I'm thinking about those science fair projects that we had back in the day, the one I always remember because everyone did it, the one that they did it the night before,
Hmm.
those plants with the that with the light, cut it because they wanted to see which way the plants grew toward the light or that sort of
Exactly.
thing. But so with the environment in space, it's not necessarily looking at light; it's looking at
No.
other things like
Yeah. So
microgravity
what
and
we don't understand how plants grow on the ground, or we kind of take it for granted, is that the roots, because of gravity, grow down. So that's their sensing to go down in the downward vector,
right.
and then the leaves go up towards the light. In microgravity, of course, we don't have
We don't have it
the
down.
the gravity. So researchers are looking at different stimulus that would allow the plants to grow. And of course, plants are a great food source for long duration space flight. So it's a really critical investigation.
Sure, very important. And so the Material Science Research Rack, I understand that that is a component that will be coming down along with these science experiments.
Yes, that is one. The Material Science Research Rack is a facility that facilitates aluminum, metal processing
Hmm.
on board the space station. And what they look at is melting it and then solidifying it. So those material samples are actually coming down, and researchers are excited to look at the recrystallization patterns that happen a result of microgravity.
Yeah,
And so that's some of the hardware and samples that will be coming back on the
sure.
Dragon
And
capsule.
what that is looking at is also, or the benefits of that particular research is to improve, to have improvements on alloy materials here on Earth.
Exactly.
Alloy materials being things like brass or silver.
Exactly.
So it's fascinating. It's just
Very
amazing. I'm
fascinating.
always amazed. Sometimes you just see them out there. They're, kind of floating around, but they actually are doing work that is beneficial to us, not only to get us further into space, but also back here on
Yes,
Earth.
that has an impact on life on Earth.
Sure. And any other
Yes,
things that are coming back?
there's some other hardware components coming back from the Combustion Integrated Rack,
Okay.
which is a research facility that facilitates combustion research. We also have some double cool bags coming back. So it's a very exciting time for researchers so that they can get their research back on the ground and continue the analysis of all these investigations.
Great. Well, thank you so much for all the information. This is very exciting news. We are looking forward to to that SpaceX launch, and hopefully
We are.
it'll get up there, it'll dock, and then it'll return all that good stuff back to us and here on Earth, and you guys will have lots to look into and
Yes.
help improve our world here on Earth.
Yes.
Again, thank you so much for coming
Thank you
out.
for having me.